Good morning. Welcome, everyone. Thank you for joining us for today's webinar. My name is Tatiana Hribac, and I'm a part of business development team at IBA Group. And as maybe you know, IBA Group is one of the largest IT providers in Eastern Europe. And today we are talking about Mainframe DevOps best practices, presenting by our experts from Mainframe Center of Excellence, Yulia Voronina and Tatiana Ignashchenko. And in my introduction part, I would like to share some background information about IBA Group, about our speakers, and some words why the underlying trend of Mainframe appears to be clear. Just a little housekeeping before we get started. During the presentation, you might have some questions. Please type them in the key question and answers box and in the Zoom control panel. Of course, chat box is also available, but in this box, please share just some information for the audience, but all questions please keep typed in questions and answers box. And just to save time, we skip the option raise the hand. And of course, during the presentations, our speakers will bring up all the questions, and there will be time for questions at the end. Giving you a little bit of about IBA Group. As I mentioned before, IBA is one of the biggest IT providers in Eastern Europe, and since 1993, IBA has delivered its services, and IBA covers all kinds of services and the full circle of services. IBA has partnership with world-leading IT providers like IBM Corporation, Rocket, SAP, Oracle, Microsoft, and WorkFusion, and more others. And our focus domain where IBA Group is working in mainframe, enterprise applications, SAP solutions, clouds, artificial intelligence, intelligent automation, and more others. Focusing on mainframe, it's important to know that IBA is IBM business, platinum business partner, and IBA and IBM working together for more than 27 years. And focusing on mainframe, IBA delivers all kinds of services around mainframe. For example, it's integration, installation, administrative part of the projects, transformation projects, integration, migration, all kinds of product development, development of enterprise applications based on multiple platforms, and more others. In general, in-house, we have about 2,800 IT and business professionals. In our mainframe team, we have about 500 people. And our IBA delivers services worldwide. With this slide, I would like to be specific and refers to some findings illustrating the current situation on the market. 65% of mainframe organizations experienced ME-IPS growth. 68% of the world's production workloads run on mainframes. And statistics says 92% of the world's top 100 banks rely on mainframe. 23% of the 25 top airlines rely on mainframe. 10 of the world's top 10 insurers rely on mainframe, and 71% of Fortune 500 relies on mainframe. here I would like you to think about the significance of these figures. And Forrester Research Mainframe in the Age of Cloud, AI, and Blockchain predicts the following picture of mainframe in the foreseeable future. 50% of businesses in Europe and in the United States are looking to expand their mainframe capabilities. 77% of organizations are prioritizing mainframe modernization now. 38% are planning to adopt DevOps for the mainframe strategy. And in next 5 years, the mainframe market is expected to grow by a further 4.3%. And the value of these is about 3 billion per year. As I mentioned at the beginning, our speakers today, Julia and Tatiana, who will be presenting some insights and know-how from IBA. Julia is the DevOps engineer and Scrum Master. Julia is engaged in that stack development, DevOps building, agile engineering, and test automation. Julia is a Scrum Master for 2 big Scrum teams. And in background, Julia has experience in SDET on Python, building and testing backends of infrastructure of Z teams, creation of CI with related infrastructure of a complex mainframe system that included C, Java, DB2, and TWS-Z. And about Tatiana. Tatiana is the DevOps engineer as well. Tatiana is focused on CI and SD development for mainframe-based applications, engaged in test infrastructure development and support, working currently on DevOps tools integration and development of the test constructor approach, and Tatiana prefers to code mostly in Java and Groovy, just in case. Now, with any further ado, we will turn the time over to our speakers. I'm stopping my translation. Tatiana, Julia, you're welcome.
Yeah, all right. Hi guys, so let me share my screen with our presentation. Hope it will appear in a second. Does everybody see my screen? Does everybody hear me clear?
Yes, it works.
Okay, so it was the longest presentation of me today. Sorry for that. I'm just Julia. I'm going to talk to you today a bit about DevOps on the mainframe. Hopefully, it will be not useless for you. It will be interesting, amazing, and yeah, ready to get started. So.
Hello, I'm Tatiana, and today I will focus more on challenges and successes that we have in the field of building DevOps for mainframes. And we'll talk about the DevOps in general a bit.
Okay, let's go. And so why it did not work? Sorry for that. Okay, I know, folks, you have been predicting the imminent demise of mainframes for years. So far, you've been wrong. And we are here and talking about something interesting around this topic, right? Although the roles of mainframe have certainly changed somewhat over time. Mainframes remain essential in a number of major industries. So we are starting from the point from the bottom of the slide, and mainframe remain alive and well. By the way, how I see the future for the mainframes. First, multiple operation system. There are already Z-Linux and Z-OS and ZVM, maybe some more interesting Linux distributives, or at least Z container extensions gave us some possibilities to run something interesting on Z. Also point adaptation to adoption to the new IT trends. Exactly. I had a presentation called DevOps for DevOps around the mainframe, and all things like AI ops and stuff. We see to the marketing articles of IT vendors and next to the word Mainframe. So all right with that. And I think this is continue to happen. That was this fear because yeah, Mainframe is quite adaptive for the trends. While it's hard to know exactly which new trends may arrive in the IT industry over the coming decade, it's good bet that Mainframes will adapt to them too. Okay, we are going to get more powerful, sure. For me, that's why we are all work with Mainframes, and this is a key aspect. One of the factors that drives Mainframes' contributing popularity is their ability to the process so huge quantities of data, is big data processing and big power really. In this respect, Mainframes have long been ahead of the cloud and commodity servers. So yeah, and also get smaller. Modern Mainframes, of course, can be as small as a refrigerator, you know. But yeah, Mainframe will probably continue to grow smaller in physical size, and they will involve our the common decade. Easier integration, the next my point. So I do believe that more than 2 years ago, I started work as DevOps on the Mainframe platform. It was almost nothing to integrate with Z. No connectors, no plugins, all we've created from the scratch. But today, industry gave us IDE, plugins, connectors, Git on the Mainframe, everything, right? So, and I think that Z platform integration will grow. And yeah, the platform became much more ready for integration with nice pipelines, of course. Cloud platform, I do believe that Mainframe as a powerful server will be used under the hood of billions of hybrid cloud architectures built by engineers around the world. And of course, more open, sure, key advantage and problem of Mainframe world that it considers themselves as a stable and close community, which ensure the security of their product, but so hard to learn and understand that system, so hard to play with Mainframe technologies, that the privacy and higher security became a problem. Where to find engineers for that system, at least that question. So yeah, it needs to have more open to remain alive and well.
As the wish of Mainframe community to become more open in some spheres of mainframe development is actually a trend of the mainframe community nowadays to best practices, not only from the inside of the community that has been developed sometimes from the 1960s, but also to select best practices from so-called distributed world. I mean more common Java, Python development, online application development, mobile stuff, and so on and so forth. And the DevOps is actually the case here. It has the origin in the distributed world and began as a wish to automate as much as possible in the development and delivery life cycles. DevOps is a trend in software engineering sphere for 5 or 3 years. But still, even in the distributed world, it is some kind of a legend. Everyone is talking about it, but no one has seen this magical DevOps. So this is the unicorn type of story. It starts in every company in a different point of time, and the starting of DevOps implementation depends on the size of the company. If you have very, very small teams, there is actually no point to create a DevOps for one or two software engineers in your company, but when your organization is really, really big and you hire hundreds of engineers, then of course you would like to speed up your development. And furthermore, I doubt that it's easy to find an engineer who likes to do the same work every morning, like installing mainframe packages on test and production environments. And a good engineer tries to automate as much as possible. That's how the DevOps appeared. But within all this automation, we got new tools, and when we have new tools, we have to change the way we working with them, the way we planning our tasks, and the DevOps transformation within the automation problem bring us a request to change the culture of our work. So to sum it up a bit, the DevOps currently is a set of best practices for engineering automation and change the culture of your organization. This is how the DevOps is applied to the whole IT world, but a lot of true mainframers are skeptical about it, because if it is a legend even in distributed world, they doubt how the DevOps can be applied for mainframe. But if we will pay more attention on the definition on this slide, we will see that DevOps is not about some architecture specific, not about the size of your community, and actually not about the product you develop. It can be it can include very, very high risk, or be just a simple, I don't know, Android application. But still, the DevOps is not about such a specific. If you have an organization, you have qualified engineers, and you would like to develop your application fast and ensure its quality, then the DevOps is really a solution for you. Of course, for some non-typical projects, most of the mainframe application are not very typical, you will require some more magic. For mainframe, it is connected mostly with the technology stack that mainframers use. First of all, well-known CI/CD tools were developed for the distributed world, mostly for Java and Python, maybe JavaScript application installation, and there is no so many integration with mainframe, and this is the thing that you need to discover in this area. The same with the test automation framework, coder review. You will need to add a lot of custom code, but it is only the technical problems that engineers like to solve. So we will talk a few words about which skill set we use and technologies we consider important when building DevOps for mainframe.
Okay, so as a DevOps engineer on the mainframe, what tools we are play with, what technologies we touch. I'm going to talking about this right now, and let's look into it a bit deeper. Yeah, we built CI/CD pipelines for more than 40 teams already who develop their ZOS application, right? Our goal is rapidly and a good quality shipment of every Z story, each code change to the production environment. Application which our teams developed, we support contains some logic part, usually C or high-level assembler code, or PL1 or COBOL code, and some mainframe native languages, I would say. And together with that, there could be the Java, Node.js application, especially if we have web interface or mobile app, and also of course, DB2 for the queue message queries, CICS transactions, manager for the, yeah, stuff like that. So we built one push button CI/CD pipelines for such application. We automate infrastructure around these big machines and usual Windows and Linux servers. We could deploy distributed code along with Mainframe native code through the environments as one solution and using one button. So our DevOps team works with applications connected to the Mainframe, and it's possible to use DB2 for the OS or other Mainframe features, right? Again, together with any distributed technologies. On this slide, we collect and gather everything we need to play with. So on the left side, you see some embedded technologies and more modern technologies on the right side. I did not mention here IDs, and sure that forgot a lot, but at least here you see things such as ZOSMF and yeah, some Mainframe features. We really need to play and integrate all of these stuff together. And on the right side, yeah, you see the technologies we play inside of our pipelines and integrate all together too. So IBM Urban Code Deploy, for example, use as our engine or executor for the pipeline goes. So Jira, of course, Git. So sharing path scripting also it's quite big part of our work. I would say that we have to script something on Groovy because most frequent case and some tooling like Jenkins are coding on Groovy, so Yara for some custom code in the Unix. So right, it's quite a long list of technologies we have to play to make it possible. Make it possible, I mean, yeah, DevOps pipeline to deploy Mainframe and distributed code is one solution. And yeah, pains of Mainframe-based application or problems. First one is manual operation, still for many teams. Of course, every organization invests in automation, but still non-automated infrastructure in the most cases, testing to Vazi and Galas as example, really nice things, but not everybody aware of it, not everybody tried it, and yeah, testing is still a thing here. Manual raising of change requests almost everywhere. Oof, we have a lot to do, really still manual operation while we invest into it. We all invest into it. Culture. Previously here was a point about long development life cycle in that presentation, but I decided to change it again. Yeah, all of us invest a lot to speed up the process of delivery. But actual problem is that culture is still a thing. Said that people do so, they continue to be old believers and reject any attempts to automate around them, thinking that this is not about Mainframes. Don't know why, but still a thing. Version control system, not a really big problem and became less a problem, but still, right? So Git on the Unix part of Mainframe exists, but yeah, not really integrated in every company, and still the problem to build the right DevOps here. Limited set of automation tools. Almost all tools you use for Unix or Windows system, of course, not available for Mainframes. For example, Jenkins has just 1 or 2 plugins to work with Mainframe system. All that integration features are growing, of course, as we told. and we see it. But anyway, you could easily find a lot of cool tools and features for any platforms, and you will not find it for the Mainframe. And my favorite point, poor visibility and control at all stage. It has nothing to do with transparency, really. A usual Mainframe development is a black box for everybody. How everything goes there. Yeah, solution we found, and actually for us and for team we support. As I said, we use IBA Group code for deploy Mainframe and non-Mainframe artifacts. We called it UCD. So yeah, it's our main and key executor for our CI/CD pipelines. Unified solution. We came up to this idea several years ago, I would say, and yeah, we built similar unified pipelines for many time and for many teams. So currently it's like one pipelines for many teams we support, and we just need to add new team into it, right? Because we decided that it a lot of work to do to support many pipelines for many teams. It's really time consumptive. So yeah, we just create really flexible pipeline in which we in a really quick way could add a new team and adapt this pipeline to the team accordingly, and then it will be run for these teams in the same way as it will work for an hour. Tatiana will give you more details on architecture a bit later, but yeah, unified solution is a thing we've at least used inside of our organization. Automatic code review, lack of tools and possibilities to run the code scanning for the Mainframe languages and for Mainframe databases too, send us to develop our own code review modules, right? And yeah, our own code review modules we use to check how everything goes with applications we develop, because as you know, for example, SonarQube has just enterprise plugins for PL1 and COBOL, but nothing with high-level assembler or stuff like that, and nothing for GB2, for instance, too. Scalable pipeline constructor, yeah, it's our idea, our own idea. The constructor is continuation of unified solution, where we try to gather all possible tools and technologies we could include into one pipeline, but we have a separate slide for explaining it. Just remember that we promised to explain you what does it mean, scalable pipeline constructor. So, and sentences on the right side, more or less the values we see when we follow the DevOps in the organization. Quality improvement by reducing manual efforts. Yeah, right. So it's always prone to mistakes, and this point here. Delivery software quickly, reliably, safely, and blah, blah, blah. That's really true in case you live in culture of automation than we do, as we do. And yeah, that team became more open to innovate. It's also true. You just have to believe in that and build this culture of automation around, and everything will be possible to you. And existing tool set harmonization and standardization to provide a common code base and deployment processes using the best engineering practices. Exactly the case for us, because we have a unified solution for many teams we support, right? So it at least gave us the possibility to standardize the tools our team use, and at least in our organization, right? So yeah, it's also the point. So now more technical details I would give you. Something interesting, right? It's our servers infrastructure for our DevOps solution, and it's shown on the slide. On the bottom, you see 3 Mainframe hosts, development, test, and production, very usual. We deploy Mainframe code through that environment. On the top, you see 3 Linux servers where we deploy the distributed code. And UCD, Open Code Deploy Server, we use as a giant for our CI/CD continuous delivery, continuous integration, as it also more or less analog of Jenkins, right? We install our UCD agents on every machine we use in our architecture to be able to run all we need on dedicated machines. Interlayer server, it's Windows 1 in our case we use because our test automation tools, RKM or Qtest, TMT, right? We use the abbreviation TMT for test management tools. They have some executors and we need to run it somewhere. So in our case, we use some host Windows machine, but it could be any. It's just in our case because we have such a server. Also, we use this interlayer server to run and to call some REST API scripting, for example, for Jira to make some interesting things with Jira via REST API. And so we generate some custom reports, for example, that machine, run our custom code review here. So some technical stuff like that. I would say it's heart of our DevOps automation because other servers related to the applications we support. And this server we use just technically for ourselves. And yeah, TeamT on the right side, as I said, is a test management tool was given us to integrate into pipelines. It could be any tool you use. The value stream runs from the left to the right, as you understand, and automatically, of course. So another view of our service architecture, just another view. Again, Urban Code deploy client server on the top, and agents run on any machine we need. And on the right side of the slide, you see the plugin, UCD plugin for ZOS, and the features we could use from UCD to play with Mainframes. And yeah, it's quite good, and this is the reason why we're working with Urban Code, because Jenkins don't have such cool features. For example, we could run any MVS commands from here. Of course, with the job, we had a connection with USMF. We had features to deploy Mainframe datasets, Mainframe artifacts, etc., etc. I'm not talking that it's full list we need. Custom code is always welcome in our DevOps life, right? But that's a lot, and at least bigger than Jenkins could provide us. And yeah, Tatiana will give you some details on our pipelines architecture, I think, in the several seconds. Tatiana, please.
Okay, just a short glance of how we gather all the architecture that Yulia mentioned. Under our solution, we have a CI/CD tool that is kind of an engine for our pipeline, and which execute plugins or our custom code to automatically perform every step of software delivery. We start with development environment with COBOL, PL1, Java, or even C++ programs, some DB2 functionality, other MVS features like Tivoli workflow, Tutor, and so on and so forth. All our engineers work on development environment. Once they finished their part of work, they initiate the pipeline run. The pipeline is initiated not from the CI/CD tool directly, but via shell script, boost tool utility that we, as a DevOps team, provide them. We do not provide access to the CI/CD tool for our developers because it's kind of unnecessary for them to go into details how our solution works, but we still always happy to introduce some technical details for them if they're really interested what happened later with their code. Our CI/CD pipeline, once it is started, send the data sets and program models to the test environment. That is a mainframe as well. Some technical steps like sending notification to Jira or some other team collaboration tool I done with the help of our Intel server Windows machine, but it mostly depends on the type of integration we have on this part of our pipeline. It is important to mention that since the developer runs code in our CI/CD tool, all the process is controlled by status handling. Status is in Jira. So in case the status is incorrect, the pipeline won't start or will stop at the middle, so you can control the CI/CD tool execution via statuses in Jira in one place. Then the code is installed in test environment and we execute preliminary prepared test automation. We insist for test automation to be prepared before the development. We're trying to apply test-driven development in teams that we are working with. That's why when the code is already on test environment, tests are ready, and we can execute our custom testing models and the code review if it is required. We mostly code our program models on Java. They are custom and quite specific for each project we are working on. The results from our program models are sent to the test management tool. It can be ARC, QM, test, trail, and so on. And the result is going back to the CI/CD pipeline. If everything is okay, the CI/CD pipeline stops for user acceptance testing. We understand that most of the software we develop have quite high price of errors. That's why a lot of engineers insist to have manual review and testing. So we have a possibility to make a pause after automated testing, but if a team agrees, this pause can be removed. Anyway, once the code is double checked, we start the production installation. Automatically, it is done by our pipeline. Of course, during the pipeline works, we send a lot of notification to Slack and Jira, so every member of a team, developers, tester, business analysts, managers can track what is happening with the code changes, and in future build some statistic reports and so on. This is the short description of how our pipelines work, but even in this picture you can see that we have quite a lot of integration. We need to integrate Mainframe with CI/CD tool, our CI/CD tool with messengers, with Jira, with our program models, and so on and so forth. But when we are creating a solution for different teams that have different test management tools and so on, we face the problem that for such an integration we can spend quite more time, and it would be great to have already preliminary prepared scripts for variety of tools that can be used here. That's why we started to collect integration scripts from various projects that we have, and in this way we come up with the idea of unified solution and constructors. One of the example of our script is integration between Mainframe and CI/CD tool. To send data sets, we use so-called boost tool utility. Using it, we can describe data sets that contains code changes in a simple XML file. It can be edited on TCO session in green screen. It can be edited in on your personal computer, no matter. And then this XML script is just put in as a source to the GCL job that we provide as a sample to our developers. Using this sample and changing only paths to ship list file, developer sends the data sets to our CI/CD tool, to so-called code station in Urban Code, where artifacts are stored and then can be moved to other machines, I mean test and production environments. In this way, we collect a lot of scripts, and Yulia will talk more about integration we have available currently.
Yeah, so I promised, and it's here, our DevOps constructor. So again, fundamental difference of the pipelines, of the pipeline constructor and of what we have now is the ability to use and mix different operation systems as a source, mix version control system, VCS, right? Application management system, test frameworks, dependent on your business needs or on what your business have, right? We can select between several options. It's possible to use executor, UCD or Jenkins. We already have scripting preparing for both platforms, right? For both executors, we could use Unix or Windows or any cloud solutions as a source to gather your artifacts. Also for team collaboration perspective, from backtracking and handling everything perspective, so we could and have the ability to integrate our solution with RTC, Rational Team Concert. It's IBM tool who are not familiar with, or with Jira, all of you know. So tests could be executed on ZOS, and cloud, and Unix, on Windows, in containers, in multiple browsers, again, all depending on your needs, right? So according to the TMT, on to test management tools, currently we are ready to integrate everything with or Qtest or TestRail or RPM, again, depending on what tools you have currently, what is used in your organization, and yeah, also based on the framework you use for running test automation, could be something from XUnit family or Selenium or TestNG or PyTest. We will execute for you everything you need and attach the result to the test management tool. We already have the possibility to integrate Grafana and PagerDuty for monitoring and alert, and yeah, RTC or Jira help desk for support if you have so. Of course, Slack is quite popular right now, and we have such an integration and found it useful when in one Slack channel all team and all stakeholders are notified about your deployment. It's really interesting and nice to have. So yes, we can see we can be flexible and choose the infrastructure configuration, yeah, depending on your needs. So generally, there is inside CI and CD, they are two fundamentally different processes, right? And the goal of CI is to build artifacts, and it's presented here from the dev environment to our code station. There is on the left side is our CI part, and everything what is in REST, it's our CD part. CD is usually to deploy artifacts and environments. And now Tatiana will share some details on both processes, so on CI and CD, of course.
So here on the left side of our slide, you can see how actually one of our pipeline looks like. It is the process to build a version in our UCD code station. As we mentioned, such a process is triggered by a GCL job that we provide to developer, and the application data sets are already stored in our code station. However, before starting deploying it, we need to prepare our infrastructure. Of course, as a first step, we check Jira statuses, make sure that there is no mistake, and we have real task created in our team collaboration tools. We generate some deployment information here, for instance, on which server this particular version should be installed, and so on. Then we create infrastructure backup that include backup of data sets in case it is not mainframe directories and files. Infrastructure backup also include setup of existing connections between servers, like database cataloging and so on. So we create this specific snapshot of the infrastructure that we have. Then we do the infrastructure deployment as a preliminary step, including creating files, installing the connections between our target server and site servers, and so on. The backup version of the code is as well stored in code station and can be installed back in case something went wrong with our deployment in future, or we will need to just roll back it because test failed, and so on. We create our application version in code station that we will need to install on test and production system as a next step. We clean up infrastructure, and sometimes we add to this process automatic execution of the deployment of this version. Now a few words what happened when the version deployment happened. This process can seem a bit smaller for you. However, the logic here is much more complicated. Again, all starts with Jira statuses handling. Then we provide code customization that is done by our custom Java modules. It's quite hard to find proper it's quite hard to make ZOS environment the same, because some of them have been set up 10 years ago. Some engineers are currently not working with us, and it is kind of a snowball effect that development, test, and production have different parameters. That's why code customization is always needed. Once the code is customized, we deploy our application to test system, allocate data sets, execute installation jobs, especially in case of some database changing. When the code is installed, we execute our custom code review, execute test automation. As I mentioned, it is prepared preliminary. Once all is done, we run some small processes to deploy application on prod and send a notification. In case it is needed, a team can go to production system, do some verification here to make sure that the code changed is applied. These processes together contains more than 80 component processes. Each of them have a lot of integration. Most of them, unfortunately, can't be done via existing plugins. We like to code here in our team. That's why our custom integration appears every time we can't find proper plugin for a tool, or we can't find a good tool for code review for, I don't know, COBOL or PL1 code for our installation GCL job. When we can't find such a tool, we have to create our custom models for that. These custom models generate a lot of reports that should be attached to our team collaboration tool, and here again we need some more integration. And the same with creating different kind of triggers for our CI/CD tool outside it. I mean on the mainframe or on your personal computer to push this deployment button by submitting some scripts. For installing integration, so we use REST API calls, mostly in cases when the tool is available, but we just don't have a plugin. In this case, we create a lot of API calls, and I think it's the most funniest part of the job, just to understand why this API call doesn't work, even if it is the same as in documentation. Every time the IP calls seems very, very easy, but every time you have some troubles and investigate the root cause for the full working day. So the next technology is just creating modules, program modules in Java, and it is mostly about some big steps of our pipeline, like test automation. We just execute our program module on our Intel server using bash script, for instance. And of course, for mainframe specific stuff like executing Tivoli workload scheduler application and something like that, we don't have a other option than write a GCL and Rex program to automate some tasks. and we have a lot of GCL jobs as well in our DevOps repository. But developing all the integration and automating everything is not all you have to do with DevOps transformation. As I mentioned at the beginning, DevOps include not only best practices for automation, but best practices for organizing work in your company. That's why we need a lot more here to do from management perspective to accomplish DevOps transformation.
Yeah, right. To do not be to do not run out of time, I'll really quickly talk about transformation. On the left side of the slide, you see the Gartner report that team keep growing, agile and DevOps inside of organization, and in that case, it doesn't matter either to be a Mainframe organization or Amazon or something. It doesn't matter really. And yeah, if you would learn a bit about Mainframe agile transformation, I really had a session this year on the GSE about that called Vanilla Mainframe Agile. So yeah, you could listen and find the details here. And because I have no time, just would like to mention several problems and how we think that we could resolve this problem of transformation in our mindset. Right. So first problem is intrinsic slackness and long delivery time frames. So yeah, it's really the problem and the Mainframe development that the cycle of development quite a bit longer than in distributed world, and everything should be adapted around this. So I just highly recommend to use longer iteration for the Mainframe organization. Just you could use 3 weeks or even 1 month iteration if you need, so if it's used to you. So why not? Don't try to be like on the wave of fashion and try to be a Scrum team with 2 weeks iteration. Also, multi-tier testing and test flexibility is a problem on Mainframe organization. You can't easily use Apache JMeter or something on the Mainframe to emulate the billion of environments and to try to compare those environments, etc. And it's at least hard, right? But Zeus provisioning and self-services became a reality. Some companies introduced such features using the Ansible, right? And it's quite interesting, and I highly recommend you to read about and try to do something on that direction, because it's quite amazing for Mainframe to be able to easy provision your Zeus instance with DB2 CICS inside and try to run your application here. So yeah, it's how we have to adapt our mindset too. And yeah, finally, many Mainframe engineers hate agile world. I absolutely agree with that point, and just stop telling them it. If you'd like to run something flexible in your organization, if I talk about methodologies, right, when we work, just don't tell the engineer that you are working with agile or following the agile. Just try to adapt everything, all advantages agile gave us to your organization, but stop telling to the engineer that world and everything that works for you. So yeah, maybe
summarize it up just a bit. We are here because we love doing DevOps. This is a great opportunity to work with dozens of tools, and mainframes do DevOps even more fascinating because some of things you have to do from scratch, even if in distributed world it is already done. So we have a quite nice journey when transforming mainframe organization for using DevOps. Thank you for your attention.
Great. Thank you very much, Tatiana. Thank you very much, Yulia. Now